All right, hello and welcome. Thank you for joining a webinar that we're very excited about, introducing the new Digital TrueFlow Grid. I'm Bill Graber with TEC, or the Energy Conservatory, and you can see there's a couple gentlemen with me. They're also going to be participants in this. It's Steve Rogers from TEC and Ed Jonawak from ACCA. So what I'm going to do is I'm going to take you through a series of brief introductions before we hand this off and get some discussion going with both Ed and Steve. So let me start by introducing both of them. Ed Jonawak is the manager of HVAC design education for ACCA. After many years with Eastern Heating and Cooling Council, he's got 35 years experience in the HVAC industry, and he teaches across the country. He's got his master HVACR license in the state of New Jersey, and he's helped write several industry standards and certification tests for ACCA, NATE, and BPI. Steve Rogers is the president of TEC. He's got over 25 years experience in pressure and flow measurement with Emerson and a brief time with Dwyer as well. He's a mechanical engineer from BYU. And Steve really spends a lot of time on committees focused on making really good measurements. And that includes ASME, ISO, and ASHRAE. As I said, I'm Bill Graber. I'm the marketing guy with TEC. I've got over 25 years experience in pressure and flow measurement with Emerson, and I am a mechanical engineer from the University of Minnesota. Now, I mentioned earlier that Ed has been with Eastern Heating and Cooling Council for many years until he just joined ACCA, and we like to tell him, back when we knew you, you looked like this, Ed. But in all seriousness, Ed, our congratulations on recently joining ACCA. That's great.
Thank you.
Yeah. So our agenda today looks like this. I've gone through most of the introductions, but I'll do one more where I'll take you on a high-level overview of the TrueFlow. But then we'll talk with Ed and Steve about, why are we so focused on measuring airflow in HVAC, and what are some of the alternatives and options that have historically have existed for doing this measurement. Then we'll come back around and Ed and Steve will take us through how to use the digital TrueFlow to make these measurements. And then I'll come back at the end and take you through a little more detail on what is available and how do you select the product and where to learn more. So what the goal of this product has been is to be really the first easy to use air system analysis tool. That's been the goal. How does it work? You've got a TrueFlow grid, a digital TrueFlow grid, because it Bluetooth connects to the app. You also need a DG8 pressure gauge that Bluetooth connects to that app, because in addition to measuring flow, and while you're measuring flow, you need to have a pressure reading in your supply plenum. Now, if you already have a DG1000 from us, that will also Bluetooth connect to the app. The idea is the app drives the entire process. It helps you make the right measurements in the right order. It collects that data. It helps analyze that data and make suggestions about actions that should be taken if the airflow doesn't look good. So there's two main methods or processes that you can do with the app. One is to measure flow only, whether that's just by your own commissioning standards or to do a grading per ACCA ResNet 310. And then there's also a pressure and flow analysis. That's the one we think delivers the most value. This is what the TrueFlow looks like. The front has an air in on it. It's got our logo and the power button. On the back side, you'll see it's got a calibration sticker and the air out. On the top, you'll see there's the USB-C where the digital TrueFlow is charged. And then there's a series of filter adapters of the most common filter sizes so that the grid can snap into these adapter plates. And that's how you're going to get your very best measurement. As I mentioned earlier, some of you may already have a DG1000 or DG8. If you have those already, you don't need the full solution kit. You can buy the grid kit where we don't include the DG8. That's really the offering. The last thing I want to make sure you understand is this is what those 8 adapters look like. And so again, you can see the 7 most common have a dedicated adapter plate. The same grid snaps into all. And then here on the bottom right, you can see the cut to fit. And then you get the gasket material to attach. If that's what the product is for, why do we care to measure airflow in HVAC? And for that, I mean, Ed, you're the one on this webinar that's got 35 years experience. Take us through, what's involved and why is this such a big topic?
Well, the biggest reason that it's such a big topic is the ability to accurately measure airflow is something that our industry has struggled with for a very long time. In previous conversations we've had about this stuff, I always go down this road where I talk about the 4 things in our industry that we're focused on. And I was going to try and control myself and not do it, but I can't help it because I get these ideas in my head and I got to get them out, or it's all I think about for the rest of the time we spend together. So real quick,
you go, Ed.
Electricity, refrigerant, or the refrigerant circuit, and combustion, along with fluid movement, are the 4 things that we focus on. Electricity is really easy to quantify. We take a meter and we measure pressure and flow. And you don't say that, you say amps and volts, right? But I think everybody gets that. The refrigeration circuit, we attach either analog tools or modern Bluetoothing tools, and we measure superheat and subcooling. We can see if a coil is starved, flooded, or in a proper condition. So we're able to quantify the process. And again, it's simple. I mean, not super simple, but a technician that is even mediocre can perform those tasks. And I don't mean that in a derogatory way. I'm just trying to set some expectations.
Yeah, maybe
then we get into combustion.
Learning, right? Someone who's just learning.
Absolutely. I'm of the opinion that somebody who is in their second summer and can basically figure out and fix 90% of what they come across knows how to measure superheat and subcooling. So that's the way I look at it. Like a five summer guy, he's fixing everything. And the only time he's calling for help is if it's something that's really bizarre. Yeah. But your second summer, your third summer, you're a 90%er or so. You still need some assistance, but there's nothing wrong with that. You can still be, somebody that generates revenue. And I try and shy away from that at times when I explain stuff, but ultimately that's why we do this. We do it to make money, and there's nothing wrong with saying that, but we have to, manage expectations. And now I'm going to start using words like positioning, and I'm not. So let's get back to what I know. So we went through electricity. We went through the refrigeration circuit. We want to talk about combustion, and quantifying that combustion process is not difficult. You drill a hole in the pipe, the vent or whatever you want to call it, and you stick a meter in, and then maybe we can adjust some stuff. And in some systems, there's not as much stuff to adjust, but ultimately we can measure the combustion process, or the word I like to use is quantify it. So we just identified 3 of the 4 that are easy to quantify. And then last but not least is that fluid movement. And I like saying that. And I used to just say airflow until I had a conversation with Steve one day, and he explained to me that anything that flows can be described as a fluid. And I'm like, well, I'm going to use that because that's going to make me sound smart. So that's the way I've run with it. But I'm talking about airflow. And you can make air conditioning systems, you can make heating systems work really without understanding airflow. And I think that's why, as an industry, we've gotten away with it for so long. Mm-hmm. But you can make air conditioning systems match the requirements of the house so much better if we can quantify that flow. We can make systems so much less problematic if we can quantify that flow. Everything goes back to knowing an actual number. We can make them work better in an arid environment. We can make them work better in a humid environment. There's just, and I don't even like using the word tweaking here, but we can tweak them so that they perform the way we want them to. Stand with those 4 things. 3 of them, we're looking at a meter that's given us a number, and it represents a target. And a lot of what we do to estimate airflow through systems isn't giving us an exact target. So it comes back to, once you understand the whole airflow thing, it's probably easier than the other 3 disciplines we're talking about. But until you get there, it's the confusing one. And as long as air's coming out of the vent, hey, it's working.
Steve, maybe you can take us through, obviously, if we're saying that there's a target, Ed just got done saying there's a target airflow range. What happens if it's too high or too low? What does it mean if it's not in that range?
Yeah, exactly. So airflow on an HVAC system is a Goldilocks story. That's why we got the little graphic here. And it can't be too high and it can't be too low. You get a different set of symptoms if it's too high than if it's too low. So, and what are those symptoms? We're going to talk about briefly here about what happens to the system capacity, what happens to its efficiency, how much dehumidification it does, and then also durability of both the equipment and the house. So, if it's in the proper range where it should be per the design, then all those things are going to be right in the range they should be. But if it's too low, your capacity goes down. Not only that, but your efficiency gets worse if the airflow is too low. Dehumidification goes up, and now that can be a good thing, and you need to understand if you need to design for that. But airflow is too low, then actually dehumidification starts to go back down, and the durability of the equipment can be at risk. You can start to have problems like coils freezing up and liquid going back to the compressor if the airflow is very low.
Right.
So on the flip side, if airflow is too high, now your capacity is higher than expected. Efficiency is better, but dehumidification goes way down. And that, better capacity and better efficiency might sound like good things, but not at the expense of dehumidification. It depends on the climate quite a bit. If you're in a humid climate, you don't want your airflow to be so high that you're not doing any dehumidification, because what's going to happen there is now you're going to have problems with humidity, mold growth, and actually the durability of the building enclosure could be at risk.
I think I get it. You're just pulling all this outdoor humid air in and just blowing it past that indoor coil, but too fast. And a lot of humidity just goes out through your ductwork, right?
Yep. Yeah, exactly. So you're just not getting the humidity out. And I've heard Ed call this situation the cave. You got a big system. You can get the set point down to whatever temperature you want, but it's going to be damp and humid, just like you're in a cool, damp cave.
Yeah, that doesn't sound so good.
What happens fairly frequently is somebody goes from an older piece of equipment where we had a coil that was starting to get dirty, maybe a fan that wasn't as powerful, but the system ran a real nice, low sensible heat ratio. It was doing a lot of dehumidification. Then a brand new high efficiency system gets installed. And unless the airflow is set up properly, you're going to have the exact scenario that Steve is speaking about.
Let me just mention one more thing. So there is a case where you want that high airflow, and that's if you're in a dry climate. If you're in Arizona, there's no reason to do much dehumidification. And so designing the system for very high airflow is a good way to get extra capacity and extra efficiency.
Yep. And so let's talk about that, because, obviously we're very excited about the Digital TrueFlow. But it's not like we're the first and only way to measure airflow, and the only other way people did it is put their hand up. There's been a lot of different methods for measuring airflow. And when we started talking about this, Ed, you told me kind of, hey, there's some criteria that you think about, with all these different methods that exist across the industry, whether you're in commercial or residential, there's a way of kind of thinking about it. You want to take us through this and just, kind of ground us on how to think about these different methods before we start diving into a few of them?
Sure. There's 3 specific words or phrases up there, and it's accuracy, time required, and tool cost. And it's pretty simple to talk about all of them. Accuracy, obviously, if we're going to do something, we want the measurement to be worthwhile. So there are ways that we can get pretty good accuracy. And I get into this whole thing at times where I'll talk about estimating airflow or measuring airflow. And there's a difference between the two. And I'm going to say from my personal opinion, there's only like 3 or 4 that fall into that measuring airflow, and everything else is going to be estimating it.
Yeah. You
can spend a little or a lot. You can be super accurate or not. And as we go through the rest of the presentation, we're going to hone in on some of the.
So one of the things, that's right. And so one of the things that, you and I've had a lot of conversations over the last year, I think the thing that you said that I'm going to pull up now is a little bit of a light bulb for me, coming from outside the industry, but understanding airflow measurement. I've worked on airflow, but not for HVAC. And it didn't occur to me just this issue that in this industry, in residential ductwork, it's about just having consistent measurements is hard. And people spend a lot of time, because they don't have confidence, they spend a lot of time trying to get measurements when they're really there to solve problems.
Absolutely. And here's another little anecdote that I'll share with you that is just dead on with this confidence in measurements. Through one of the utility programs, I taught classes for, well, over the course of the last 20 years, but for, let's call it 10 years of it, we were requiring technicians to document charge and airflow. Well, the easiest way for the airflow always goes back to, on a new install, we use the external static pressure measure.
Sure.
So the utility sponsored this, or utilities, plural, sponsored this. They gave the tech a MagnaHelic gauge that came in a kit with a hose and a static tip, or static tips, plural. I can't tell you how many contractors that I've spoken to over the years that we sent them on their merry way with this new thing to measure airflow, which they're not. They're measuring static pressure and using a chart. But I would see them 6 months or a year later, and I'd be like, "Hey, Rudy, how you making out with that?" I don't know. I think I'm doing something wrong, or I just don't do it. Why? Well, I followed the picture that you had drawn, and I, stick the tip thing in the return and one in the appropriate place in the supply, and it just pins the meter. So I kind of gave up. And I'm sitting there like, these are the opportunities that you're missing. And I always take the measurements one at a time, and then you add them together, and you still get the same answer. But if you take them one at a time, it points out where the problem lies. And the ironic part about this is people who get this, well, they chuckle at this because it's not funny, but it's reality. We see so many bad duct systems that they're well out of the range that they should be operating in, that when they take that measurement, it's off the charts. They think they're doing it wrong, and it's the opposite. It's just, we have powerful fans, and we have bad duct systems, and we have external static pressures that exceed what we anticipate at times. So talking about that confidence, if these guys don't have confidence in what they're trying to do, they're going to stop doing it. Yeah. And I don't want to let the cat out of the bag with anything, but what we have in store for everybody is the exact opposite of that. Yeah. I'm not going to say you can't make a mistake, but you got to really try hard to make a mistake with this process. So.
Well, we hope so. And I think what you said, I really like, Ed, about, look, there's no shame in being someone who's still learning. I mean, and we all are, right? And that's I think, to me, it's fun to be in an industry that just says, let's help everybody. Let's help everybody do this right? This is not stuff to laugh at. You shouldn't be laughing at people. You should be helping them.
Oh, and absolutely.
So, and I know you've been doing that for a lot of years. Steve.
I still laugh at people. I'm not above that. I'm still like a 12-year-old.
We'll still laugh at you, Ed, but maybe not.
And I'm fine with it.
But Steve, what Ed just took us through was kind of, a criteria, right?
Yeah.
A way of looking at each one of the methods. Take us through, you developed this. First, I just want to say one thing, Steve, before I let you out of the gate. This list was developed obviously with you and Ed talking a lot, but it's also with Bill Spohn from TrueTech Tools. And Bill has been training on methods to measure airflow for well over 1 decade and probably close to 2 decades. This has been something that he's been pretty passionate about, and we've been working with him as well. Unfortunately, he can't be on this with us today, but take us through these 10 most common methods for measuring residential airflow.
Yeah. So Ed put together a good framework for comparing the different methods. The first column there after the description is the accuracy, and we just use sort of a checkmark scale to show which ones are more accurate, which ones are less accurate. 1 check is not very accurate, all the way up to 5 checks for the most accurate methods. And then the equipment cost, of course, that's purchasing the equipment, and that that's an important consideration. But a lot of times people focus too much on the equipment cost and forget the next column over, which is their time. Some of these methods take as few as 5 minutes, but others take as much as 45 minutes, depending on, how big the duct is and stuff like that. A duct traverse, many of you know, is sort of the gold standard in commercial airflow measurements. And, for good reasons. It's a good way to do it in commercial applications, and oftentimes the only way to make that measurement in commercial stuff. However, it kind of falls apart in a residential situation for a couple of reasons. The first one is that you don't normally have enough straight duct in a residential situation to get that measurement. If you look at the standards for doing a pitot traverse, they require quite a bit of straight duct, much more straight duct than you would typically have in a residential situation. The other thing is, when a commercial guy is doing a pitot traverse, he's using a really high quality, very accurate manometer. And Brian Orr will tell a story about his first attempt to measure airflow with a pitot tube, and he found out very quickly that his manometer wasn't good enough.
Yeah.
You just get unrepeatable results in that frustration that Ed talked about. So at the top of the chart here, we've got 4 methods that are in green, and these are the 4 that are recognized by the ANSI-ACA ResNet 310 standard. And they've identified these. The standard is for grading new HVAC installations, and they've identified these methods as adequate and accurate enough for doing that grading. And you can see the flow grid is the one that we're talking about today. The pressure matching method with the duct blaster is, this is really sort of a gold standard way to do it, but it's expensive. If you don't already have a duct blaster for measuring duct tightness, that's a lot of money to be just measuring airflow. And so, but it continues to be the gold standard. It takes a little longer, and it requires a little more expertise to make sure you've got it set up correctly. The flow hoods can be a very good way to do it. Depending on the situation, you might need 2 flow hoods, one for the larger flows on a single return, filter grill system, and then you might need a smaller hood to measure multiple return systems. And then method 4 is the external static pressure and the fan table. This is what Ed's talking about. This is a really common method, and it's sort of a workhorse. A lot of people that get into airflow start here, and it's a good way to do it as long as you can verify that the equipment is more or less in the same condition it left the factory. Because what you're doing with the external static pressure and fan table is you're measuring a pressure drop across the components of the system. And that pressure drop across those components, it's the rise from the fan and whatever drop is included in either an evaporator coil or sometimes a secondary heat exchanger is part of the equation as well. And so as long as all those things are in the condition they left the factory, that's a good way to do it, and you'll get good repeatable results. But as soon as the blower wheel or the secondary heat exchanger or the evaporator coil starts to get dirty, it doesn't match the factor anymore, and that relationship between the pressure drop and the flow starts to change. It's like the calibration of that method has changed. And so normally it's a good method on a new system when you're installing it. Old systems, it's very dicey. But there are cases where it might not even work on a new system, and that's in a case where new construction and the the drywall contractor decided he ought to turn on the air conditioner to get his drywall to dry faster. And now you've got a wet coil with sheetrock dust going through it, and that's a disaster.
Right.
Those are the 4 methods accepted by ANSI-ACA ResNet. These other methods have application, but as you go down these ones in the gray, it can get even harder. It takes more experience, and you have to really understand when this may or it may not work. The temp rise, temp split, that one is one that can work well, but you have to know where to get the probe. If you get the probe too close to the hot components of a furnace or the cold components of an air conditioner, you get a radiant heat loss or heat gain that throws your temperatures off, and it doesn't work. This is a situation, Jim Bergman tells about somebody using MeasureQuick, and they said, I'm getting 4 tons out of a 3-ton system. Like, yeah, well,
yeah, probably not.
yeah, exactly. That's, where's your probe? It's too close to the evaporator coil. Yeah.
Well, you mentioned that, we know that working with Jim Bergman, that he's got kind of an advanced temp rise split within MeasureQuick. That's probably probably about as good as you're ever going to get with that approach, because he
Yeah.
really does help guide and make sure you get to the right place. But it does require expertise. And how do you know that you've got them right or not? That's the challenge. It takes you're not going to train new people and have confidence that they're measuring it right. It takes a little bit of time. Is that fair, Steve?
Yeah, exactly. And just like Ed said, it's experience. And, there's a lot of people that tried this and got so frustrated that they just gave up. And that's the problem that we've been really trying to solve with the original TrueFlow grid and now with the new digital.
So I'd like to just kind of sum this up with a couple of additional comments. You guys have taken us through why should we measure airflow and what are the alternatives. And one of the main messages we're trying to get across is, look, of course we like the TrueFlow grid. We've put a lot of energy, a lot of time and money into developing a new one because we think it's a real opportunity to improve how this is done. But we by no means think it's the only valid method. And there's a lot of ways to do it. Our first message to you, if you're watching this and you're trying to decide what to do, is look at this chart for a while. And if you're not using any of these, pick one, start to do it, start to measure the airflow and start to understand how getting a measurement is going to help you solve problems. And then over time, you'll move to the right one. We think what you'll find is that the TrueFlow grid, especially with this new digital, is the one that helps you do it the most consistently and the fastest and gets you, to the problem faster. But there's a lot of valid methods. These ones, the top 4 in green are probably good ones to look at and spend some time because, the range of equipment cost is there. And, they're all pretty straightforward ways to get started. Now,
I'll just mention all 10 of those methods, even poorly done, are more accurate than the handometer.
Well, even Ed Jonawak's hand, that's calibrated over 35 days.
Maybe not Ed's hand. Yeah.
Well, this one's for the velocity and CFM. This one's temperature and humidity. So I'm packing 2.
Yeah. So, what you guys took us through, I just want to make sure people know, you guys wrote an article that was in the news in May. And it's also posted on this website, HVACairflow.com. And this is a website that, I'll talk about in just a minute. But this article takes us through the 2 things we just talked about. Why should we be measuring airflow? And what are the options and alternatives out there to measure airflow? And so if you go out to HVACairflow.com, you'll find that all 10 of those methods and other information is available to you. And this was done with the 3 of us and Bill Spohn from TrueTech Tools, as we mentioned earlier. And what we're doing for the top 4, the ones that were in green, there is both an overview and a step-by-step video that's been recorded. In the overviews, Ed and Bill Spohn will take you through, what is this equipment about? How does it work in general? What are some of the pros and cons? And then what are, some options for specific equipment you could purchase to do that. And then the step-by-step says, now I bought this equipment and I want some instruction. I'm on site. I need some instruction. And it tries to help you do that step-by-step process. So that includes the TrueFlow grid. But again, all of these other methods have it. The bottom ones, the step-by-steps are still in process and coming soon. You'll also be able to find Ed and Steve's article out there and some other things. So that's HVACairflow.com. Remember that's going to be a good resource, we think, whether you're using the digital TrueFlow grid or some other method, that's there to be a resource to say, are you measuring airflow? And how can we help you do it with whatever method you pick the best you can? So now let's get into how does the digital TrueFlow, how do you use it to measure airflow? And, I'm going to just do a kind of a quick reminder here. I said this earlier. This is what you get. This is the equipment that comes with it. Several pieces of hardware. But the real key, I think, I'm a mechanical guy. I have a mechanical engineering degree. I'm not terribly mechanical. I'm a marketing guy, right? But I like things that are mechanical. I like, we make products. But the more time I spend with this specific solution set, this thing's all about the app. It's the app that actually, to me, is where kind of the magic of this thing comes through, because it drives the process. It collects the data. It helps analyze the data and say, this is what you should go do. You know, it will do two things. It will give you confidence airflow is in the right range, or it will tell you airflow is not in the right range. Oh, airflow is not in the right range. Go look at these things. It's one of these few things. Go look for it and fix it. That sounds to me like, wow, that's actually people's job. That's what they're trying to do, and we're going to help them do it. And I think the app is the foundational part of that. And so Ed and Steve, you guys worked on this app for a long time to get it to the point where you work through that app, you make those measurements, and you get these kind of reports that say, here's a summary of what you measured, and let me tell you what we found and what you should go do. So on the left is the full pressure and flow analysis, where you made a series of pressure measurements in addition to measuring flow with the TrueFlow grid. And it might say, flow looks okay, but you've got a high filter drop. And here are some potential causes of what might be causing that high filter drop and things you should look at. And it might be something as you just have a too restrictive of a filter, or maybe even just a dirty filter that you didn't catch. But it might be that you're, something sized wrong in the filter slot or grill, and you need to make some adjustments. On the airflow side, where you're just measuring airflow, maybe for a commissioning, it goes faster, and you just get all you want is an airflow reading, you can get that. If you're a rater or associated with a builder who's trying to get HERS points and you want a grading, you can get that grading directly out of this app. So it's really got some nice reports, customer-friendly reports that also help drive the process in action. Take us through this, guys, a little bit. I've blown it up. How does the app work, and how did you guys develop? I make these pressure readings and I get this kind of outcome. How did you guys develop this?
Yeah. So when we set out to develop a new version of the TrueFlow, the history was that a lot of HVAC technicians have used the TrueFlow, and really loved it because of its accuracy and simplicity. But they tended to be the super nerds of the HVAC industry, because they were the people that when they looked at, I'm getting 837 CFM and I can do some static pressure measurements, they knew how to interpret that from their experience. And the number of technicians that can do that was pretty small. So I recognized that if we were going to make the hardware better, what we really needed to go along with it was an app. And even though TEC has a lot of experience measuring airflow accurately, and we do a good job measuring pressures accurately, what we didn't have was the experience and the expertise to say, well, how much return plenum pressure is too much? And what should the pressure drop across a filter be? And so I met Ed Jonawak at HVAC Excellence, which is the educators conference for HVAC, and recognized right away that this was the guy that probably had all this stuff in his head. And so Ed was the invaluable resource in actually being able to put this information and this experience into an app that can guide people in the right direction.
Yep. So Ed, you have a flow meter, a humidity meter, and you got stuff in between in the head. So Ed, who taught you this? Is it just experience, 30 years working, or
Well, I was very fortunate that pre-Andrea, somebody did walk me through a lot of this. Proctor Engineering, a fellow by the name of Tom Downey, held my hand for 3 days. We went through houses, and for 5 days, really. He watched me the first 2 days, and he had a scowl on his face most of the time, trying to figure out what the hell I was doing or what the heck I was doing. And then we were in a classroom for half a day, and he said, we're going to do this, 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 and this. And that was really my introduction to measuring system performance. And you got to have an accurate airflow measurement to start with.
Okay.
And so that was my real introduction to it. But over time, nothing. I don't care how much content you watch online, how long you sit in a classroom. And as an educator, I hate saying this, but hands-on is the best way to really learn something.
Sure.
So you learn concepts, but after you crawl around in a lot of crawl spaces and you start taking these measurements, and it goes back to the earlier conversation with getting frustrated and comparing it different methods and such, you start to actually learn things. My path was different than a lot of people's because I had something that the average technician simply doesn't have, and that's time. I had enough time to mess around with stuff. Sometimes I was messing around with stuff just because I didn't want to call the office and tell them that I was done because they'd find more work for me.
Sure.
I wanted to hit that sweet spot of 3:30 and go play golf, not go do another service call. So this whole process goes with once you start to figure out this path, and this is one of those things that I'll talk about sometimes that gets dangerous because we don't take one measurement and then we know everything about the system. We have to do reality checks. You have to take multiple measurements to make sure that everything is in agreement. But after you get comfortable with this, really comfortable with this, you can just look at a system and say, "Oh, that filter's too small." But I can't just say that. You can use the app or just the DG8 or whatever your favorite manometer is and pinpoint, could that be the problematic area? Oh, yes, it is. But again, you don't stop there. You do everything. Well, if you know how to do all this stuff, you simply do it. If you're still not 100% confident in where and what you're supposed to do, bam, we have it right in front of us.
Yep.
Just follow the prompts.
Yep. Yep. I think you're a pretty humble guy, Ed. And so what you're saying is, someone taught me, and then I spent a lot of time. I had time, the luxury of it, and I learned some stuff, through hands-on experience. But you've also done that for so long that, now you're involved. You're involved with design. You're involved with thinking about how these systems work. And so these rules are, they're learned over time, but also with a pretty good understanding, both real world and some theory of how should these systems be working. And, the fact that that's embedded in this app, you guys won't say it, so I will. We've got the benefit of someone with the theory and real world experience who understands this stuff, helping us guide new technicians. That, to me, is why this app is really the key to this solution, and really the key to new HVAC technicians doing a 5 summer person's job, maybe by the end of the first summer when it comes to airflow.
Yeah, and to expand on that, and I never even really looked at it that way until I was listening to what you were just saying. There's a lot of truth to that. I'm very focused on design. And one of the things that is just so valuable to somebody who's willing to put the effort in, if you do a proper duct design, you're going to fill out the friction rate worksheet, which is what I've been calling the backbone of Manual D for a long time. And you start to understand where the pressure is created and where the pressure is stolen, right? And you can take those measurements, or at least I can in my mind, and not exactly, but sort of associate them with what's on our screen right now. I don't know if the average person is going to look at it that way. When I talk to even the upper echelon of our industry, and we talk about looking at the friction rate worksheet and what our estimated values are versus what our measured values are after we install a system, I get a lot of, epiphany looks on people's faces, because I'm showing them on the friction rate worksheet where you can physically take a measurement and compare it. And if it's not the same, well, we can figure out why it's not the same.
Yeah.
And it's really easy. It's because if it's a metal duct system, the number's smaller. And if it's a flex, the number's bigger. And that's because nobody installs flex the way it's supposed to be. Or I think there's one guy out there, I think his last name's Camaretta or something like that. But other than him, nobody installs flex the way it's supposed to be installed.
Right.
So there are situations like that where I I'm also very guilty of the idea. I think people understand more than they do. And I try and create content at times where I'm looking for that last 10 or 15% because I think that's what people are looking for. And I'm wrong. I keep getting reminded lately of that. I got to start looking at and I'm not the entry level or the people with the minimum skill set. And I don't want to say in any way that's derogatory because everybody's on a path somewhere where you don't know what the next step is and you got to learn it. So, and I'm a big fan of learning new stuff because then, it's just another thing to brag about. Although I don't brag because you said I'm humble most of the time.
Now you're making me look like a liar.
No, when I start bragging about stuff, it's usually super sarcastic and I'm trying to get a chuckle out of somebody because that's my ultimate goal. I want to teach somebody, so I want to keep them entertained. And I think that's part of the reason why Steve was like, hey, well, you want to help me with this?
Yeah, exactly.
All right. So there's a lot of different things this report can do. We've talked through a lot of this, but hopefully what you see, and then we'll talk about this app in a little more detail about how the app actually works. The idea is the app is trying to reflect, if this is kind of on the far left, what Brian Orr developed is kind of here's the real world. The app tries to, show you what you're doing for measurements in that system, and in this case, you've got, an air handler. And if that's what you're measuring, it will try to make it look just like what you're reading so that as you're taking the exact pressure measurements, you see the system in front of you and you understand what's going on. Then in your summary report, you get those measurements and the diagnosis. So again, we're coming back to, we want to know if flow is in the right range. If it's too high or too low, what's causing it? This app will help you understand, do I have a supply duct issue, a return issue, a filter issue, a coil issue? Am I flowing too high maybe? And that's why I'm not getting the right level of dehumidification or latent work being done. So it's really got a lot that will help us with that. Steve, maybe you can take us through kind of on a screen by screen tour of the app.
Yeah. Okay. So the app is laid out like this. The first thing that you need to do is decide which analysis you want to do. There's really three main analyses that you can pick. The first one is the static pressure and system airflow together. And that, as Bill said before, that's really the best, the most valuable way. If you want to get the most information, that's the way to go. The other two are more for doing a quick check. If you just want to do a system airflow check, say like you said, you've just completed an install and you just want to make sure you're right at the target airflow. Say you designed a system for 400 CFM per ton. You want to make sure, okay, I'm at 415, I'm fine. The third one is also just an airflow, but it specifically follows the ACA 310 standard to do a grading. It'll give you grade, 1, 2, or 3, depending on the airflow and the range that the airflow is in. And so you pick one of those three. Let's start with the static, the system airflow and static pressure. The next step is to connect to the devices. So you're going to connect to the TrueFlow grid itself, and then either a DG1000 or a DG8 manometer. And then you start giving it information about the system. So is it a combustion furnace or is it electric heat? That's the first question. So next steps here. So the next thing we do is we need to give it the cooling capacity, and we need to tell it where the filter is, whether it's in a filter grill or a filter slot. And then for now, we just have two cooling climates, either a humid climate where we target 350 CFM per ton, or a dry climate where we're targeting 425. And there's some overlap there, so don't worry too much if you're in one of the intermediate climates. So you give it that information, and then you're going to tell it which direction the airflow is. Is this an upflow system, downflow system, or is it horizontal? And that's really to help you orient the system in your head, so that the prompts on screen are going to help you figure out where those probes should go in your system, give you a little better visual cues to help you out there. So then you actually start making the measurements. The screen shows the manometer there, and you just really look at the green tube there, and that'll tell you where in the system that measurement should be made. So the first measurement here is in the return duct. You put the tube into the return duct before the filter, and then you click take a measurement. And you repeat that process, 2 to 4 times, depending on what type of system. There's going to be 2, 3, or 4 pressures. And you take the different pressures, then you hit continue. And then the next step we didn't show here is to put the TrueFlow grid in and take the flow measurement. And then once you complete that, you get the report. And the report's going to tell you, give you a dial indication of where you're at for the flow, total external static, and then all the filter drop, evaporator coil drop, and then the supply and return plenum pressure. And as we've said, that's to help you pinpoint what's wrong if there's a problem with the flow, or maybe the flow's okay, but the pressures are off the chart because there's restrictions and you've got a ECM motor that's making up for the problems the system has.
You mentioned this already, Steve. Yeah, we didn't show what the app looks like for the TrueFlow, but this does show that, and this is just reinforcing. When you do measure the flow, it will, after you've made your pressure measurements, it will say, now it's time to put in the TrueFlow, digital TrueFlow grid, take the filter out and put in the grid. And obviously what we're showing here is whether you work primarily with grills or slots, it works with both.
Yeah. Let me just mention here, I've had a couple questions of people learning about this product that aren't familiar with it. Wait a minute. Now that TrueFlow grid, that could be a little bit more resistance or less resistance than my filter. So doesn't that change the flow? And the answer is they're right. It does change the flow. Yeah. And that's why we take the static pressure measurement in the supply plenum while you do the swap, because we'll be able to look at before, with the filter and after with the TrueFlow. And we make a correction because we are essentially, calibrating your system with the filter in it and then comparing that with the TrueFlow to make that correction.
All right. So hopefully what you've got now is a good understanding of how this tool works to take these airflow measurements and why you'd want to do this. And so I'm going to finish up just by taking us through how do you pick which of these kits you want? Well, how are they priced and how available are they? So we early on said you've got 2 versions of this kit. And the question you want to ask yourself is, do I own one of these gauges? You can see these are Bluetooth gauges that connect to the TrueFlow app. If you already own one, then you only need to buy the grid kit. But if you don't own one of these gauges, then you need the solution kit, which includes the DG8. Now you can get the full version of these kits, and the prices are shown on the screen. That means you get all of the adapter plates for the 7 most common filter sizes, the universal, all the associated accessories. If you look at this slide though, and you say, look, I know I only work with 4 of these, then you want to use what's called the custom kit, where you can go in and pick and choose which of those do I want. And so you have to pick at least one. So if we look at this example where I'm buying the one with the DG8, I can get started for a little over $1,100. If, for example, I say there's 4 adapters I need, that would come in at $1,344. Okay, so that's the full solution kit where you get the DG8 with it. Similarly, if you already have one of our gauges, you can get started for as low as $588. And that comes with 1 adapter. In that case, if you pick 4, it will come in at $795. Now that's pretty good if you consider that the legacy TrueFlow was $895 and that's no longer available. So we haven't just come out with new functionality and new capability. We're also trying to keep this price point pretty low. So you can get started on a new digital TrueFlow for as little as $588 when the legacy one that required tubing was $895. Okay, when is it available? Well, we're accepting pre-orders right now. You can go out to our store and you can place an order. Our high volume shipments will be in July, but depending on which adapters you select, it's very likely you could see these shipments by the end of June. So go on out and take a look, and you can place your order starting today. The other place you can go, as we mentioned earlier, is HVACairflow.com. There you can see Steve and Ed's paper or look through some of the other methods to measure airflow. Last, this webinar will be posted to YouTube following this event, and you can take a look at that. And other materials associated with TrueFlow and airflow are out on YouTube at our YouTube channel. All right. Hey, Ed, can you see us okay?
I can.
Okay. And so what you can see is, I'm sitting here, and with us is Gary Nelson, the founder of the Energy Conservatory, and Steve Rogers, the current president. But we also have someone else in the room. Steve, maybe you want to introduce him.
Yeah, I'd like to introduce Chris Hughes. Chris has just joined us at the Energy Conservatory, and he's going to be helping us focus on learning more about the HVAC industry. And he comes to us with the 18 years experience, and we're glad to have him on board. He's going to really up our game in understanding HVAC and how our products can help.
Thank you, Steve. Appreciate it. I look forward to working with Ed a great deal. With this TrueFlow grid, it's a pretty awesome product. I've been using it. I've had mine for about 2 weeks now, and I've ran 2 test cases that we're studying heavily. And I'm already learning on my own system at my house, where I would hypothetically thought my return air should have been bigger, but then I ran the test and was like, it's under 0.5 inches of water column. I'm doing all right.
With the right airflow.
With the right airflow. Yeah, I was stoked, because I would have normally went ahead and cut that return and made it bigger, but not necessarily have to. So it's, we've always lived by total external static. Like, if you're from me, we're fast paced in the field, moving like crazy. We're rely on the blower chart. That's where we're going with it. Now that we're going to be able to see flow and total external static, and we can compare the two at the same time, I think our technical game is going to go through the roof.
Yeah.
What do you think, Ed?
I think it is the easiest way to measure airflow, hands down. One of the stories that I have told in the past is I envision companies getting one for the salesperson. The salesperson, when he makes contact with the homeowner for his appointment, he asks them what size filter they have. And the idea kind of looks like he's just being a nice guy and is going to give him a new filter. Well, what he's doing is he's preparing, and he's going to have his TrueFlow grid set up with the exact size that he needs. And literally in 3 minutes or less, he's going to know what the airflow is, and he's going to be in a better position to explain what the duct system in that house can actually handle. And it is such a big advantage to be prepared with that kind of information. Now, that's just one way that it could be utilized, but that's probably my favorite, simply for the fact that it's the one where you really don't have to understand much beyond which is the supply and which is the return, and don't drill into the coil, and you have an accurate airflow measurement.
Yeah.
Yeah, I think it's going to be really surprising, Ed, to see how many uses we get out of this product that we haven't even stumbled across on yet. That's what I'm excited to see what's going to happen in the field. I have a feeling guys are going to text us and say, here's what I did with it. And I'm going to be like, we didn't even think about that yet.
Yeah. Right. Yeah. I mean, I think you're here and Ed's here to help us know what we should be working on.
Yeah.
Right. I mean, we've got to start here, but we don't have it all figured out. We need help, and hopefully,
And I'm hoping I'll travel enough, go see the people in the field. I'm going to be all over the United States, bouncing in different people's jobs. If you want to get me on your job, hit me up. You can email me at chews@energyconservatory.com. If I can fit it in my schedule and I can get there, we're going to measure your job on site.
Hey, Chris, I'm seeing one question here from Rick. He's asking Ed. He says, "Hey, Ed, typically we have 20 by 30, 24 by 30, and 24 by 36. What can we do about these in the South? Where they have these big filter grills."
I brought this up when I got here, right? Because most common filter sizes back home, I would say, were 24 by 30.
And you're from Louisiana.
Yeah, from Louisiana. That's what we see. Here's what I'm going to say. And this was something we talked about heavily right when I got here. The grid plate is doing a correction factor. Like a blower chart, you take total external static pressure, and then you find your flow on the chart. But that's not what's happening with the grid plate. The grid is actually measuring the flow. The static pressure read first in the supply, and then the static read for the second time in the supply is only producing a correction factor. So what I'm trying to get at is, if you mask off, let's say you have a 20 by 20 grid plate in a 20 by 30 hole, and you mask off 10 inches, and that grid plate is now fit in that hole, you're going to get the exact same results, even if you mask off those 10 inches. And you can do that all day long, because it's only for the correction factor.
The only other thing I'll add is, after Chris gave us the feedback, hey, we're seeing filter grills get bigger and bigger, which is appropriate, right? They probably need it on their return. We're actually now in development to make a bigger one as well. So that was something, we got started with the 7 most common, but we've just started on the tooling to make what is now going to be a, 24 by 36?
Yeah, the biggest will be 24 by 30.
24 by 30. Okay.
Yeah, and I'm seeing Rick saying 24 by 36. That's one we hadn't anticipated.
So that might be one where you put 3 inches of tape on each side, but we will add sizes, is all I'm saying. If we get feedback, so keep the feedback coming.
And you could make a custom grid plate, right? That's going to go with the full kit, where you can build your own. Now it's limited to 25 by 25, right, Steve?
We can make it bigger though.
We could order the plates, make them bigger if we see high demand for the larger sizes.
That's right.
But right now, just know that you can mask off the section that you can't get with an adapter plate, and it's the same thing, because you're just doing a correction factor.
So the last thing I want to say is, so what we're trying to do is get Ed Jonawak, who's busy with ACCA, who helped design this product, and we're very thankful for what Ed has done. Steve usually hands out 2 products at the beginning when a new product comes out to the people who were instrumental in the development of the product. And in this case, we have our main mechanical engineer, and we have Ed.
Yep.
So maybe you want to just
comment on that. This is something that we do that a lot of customers probably don't know about internally, but we take serial number 1 and serial number 2, and we give those to the people who were most instrumental in getting that product to market. And in this case, it's going to be Ed and our engineer internally, Chris Koenig.
So Ed, thank you for everything you've done. The work's not done, but we could not have made this solution, this product, and this app without you.
Well, I really appreciate that. I have a grin on my face that's going from ear to ear, and that's not a line. And it's pretty cool. And I know Chris with a K, so it's cool that we're the 2 guys that are being honored with this. It's a big deal to me. I appreciate it, guys.
I agree, Ed. And just, I don't know if we beat on this, but me and Ed are going to really be working a lot of content for HVACairflow.com. According to Bill, we may be overhauling that, and we're going to make it lively, and we're truly going to make a one-stop shop for every HVAC technician, home rater, you name it. You want to know airflow, it's going to be a one-stop shop to get it professionally done.
Yep, that's right. That is the goal. All right. Thanks for joining today, and we look forward to talking to you, and Chris looks forward to talking to you in the near future. Take care.
Take care, fellas.
Thanks, Ed.
Bye.